Hello students, in today's class we are going to discuss how to compute expected project completion time in project management using program evaluation and review technique, PERT. So today's session will cover number 1, discussion about method of computation of expected project completion time. Number 2, discussion about method of determining the probability of completing a project in a certain fixed completion time. So first of all, we'll try to understand the method of computation of expected project completion time. How to calculate expected project completion time using program evaluation and review technique. And then we'll understand how to determine the probability of completing a project in a certain fixed completion time. So these are the two things we'll understand first, and then we'll solve one illustration involving drawing network diagram. First thing we have to do in solving the problem is to draw network diagram. Drawing the network diagram, and then we'll have to compute expected completion time of the project. Expected completion time of the project. This we have to compute. And then we'll have to determine probability of completing the project in a certain fixed number of days. That we have to determine. Third. So these are the three things we have to do in solving the illustration. Let us first understand these two things. How to compute expected completion time, expected project completion time, and how to determine the probability of completing a project in a certain fixed number of time. Okay. So these are the steps for computing the expected project completion time. Step number 1, drawing the network diagram. This is the step number 1. Drawing the network diagram with optimistic time, most likely time, and pessimistic time of each activity. So these will be given in the problem actually. Optimistic time, most likely time, and pessimistic time. Actually, these times, optimistic, pessimistic, most likely time, actually the project managers or project executors or project engineers, they come to know out of their experience. Out of their experience, they come to know for a similar project what should be the optimistic time and what should be the pessimistic time, or what should be most likely time. Here, one thing I should tell you: optimistic time for completing a project or an activity is the less than the pessimistic time. That means pessimistic time will be always greater than optimistic time. It's obvious. To complete a project, if pessimistic time is 10 weeks, so optimistic time may be 7 weeks or 8 weeks, and most likely time will be average time between optimistic and pessimistic time. So optimistic time is the least expected time, and pessimistic time is highest expected time, and most expected time we'll have to calculate using these three time frames: optimistic, pessimistic, and most likely time. Using these 3 times, we will have to calculate expected time of each activity first, then we will have to calculate expected time of completing the job. So first of all, we will calculate we'll draw the network diagram. Drawing the network diagram with all these things for each activity. These will be given for each activity: optimistic, pessimistic, and most likely time. Using these things, or putting all these things, we'll have to draw the network diagram. And second, we'll calculate expected completion time and variance of completion time. We'll calculate expected completion time and variance of completion time. Actually, variance of completion time you will have to calculate to determine the probability of completing a project in a certain fixed number of days or months or weeks. So to determine the probability of completing a project in certain time period, we need to calculate variance of completion time. But before that, we will calculate expected completion time of completing the project. And for that, we need to have expected completion time for each activity. So, expected completion time of each activity and variance of completion time of each activity. I repeat one thing. So, expected completion time of each activity will be required to calculate expected completion time of the project, and variance of completion time of each activity will be required to calculate probability of completing a project in a certain number of days or weeks or months or period, certain period, within a certain period. Complete probability of completing a project in a certain period, we need to have variance of completion time of each activity. So we denote expected completion time of each activity by Tij. Ij is activity. From ith node to jth node. Ij is activity. For each activity, we calculate expected completion time, and for each activity, we calculate variance of completion time denoted by Vij. Variance of Ij activity. Ith node to jth node. Ij activity. For each activity, we will calculate variance of completion time. So before we move on to the next step, I repeat, expected completion time Tij is required, the expected completion time of each activity is required to calculate expected completion time of the project, and variance of completion time Vij of each activity is required to calculate the probability of completing a project in certain fixed duration. Okay, now step 3. Step 3, we determine the critical path. Critical path with the expected completion time of the activities. We determine the critical path. Determine the critical path with the expected completion time. With the expected completion time of each activity, which we calculated in step 2. In step 2, we calculated expected completion time of each activity, and putting all these expected completion time of each activity, we will calculate the critical path. And actually, in this case, we will calculate critical path by longest path method. Longest path method will calculate the critical path using the expected completion time as she calculated in step 2. Expected completion time of each activity. Using all this expected completion time of each activity, we will calculate, we will determine the critical path. We will determine the critical path of the project. Actually, the duration, the longest duration, the path having longest duration, the critical path, and that duration is actually expected completion time of the project. Now, in step 4, we will see that in step 4, we will determine expected completion time of the project. Expected completion time of the project. We will determine expected completion time of the project in step 4. And what is that? There is a summation of Tij. Remember, Tij stands for expected completion time of each activity of the project. But here we are talking about calculating expected completion time of the project, which is summation of Tij. But remember, this Tij, summation of Tij, will sum those activities, will sum expected completion time of those activities which are critical, respectively, of the critical activities on the critical path. So, now see, in step 3, we calculated critical path. In step 3, we calculated critical path. And in step 4, we calculated expected completion time of each activity. Using those expected completion time of each activity, we calculated critical path in step 3. Therefore, when we sum Tij, completion time of activities, actually we are talking about completion time of those activities which are critical activities on the critical path. So we will sum up expected completion time. We will sum up expected completion time. We will take the summation of expected completion time of critical activities on the critical path to have expected completion time of the project. Understood clearly? I repeat, to have expected completion time of the project, we will take summation of expected completion time of those activities, that means critical activities on the critical path. We will take summation of expected completion time of critical activities on the critical path to have expected completion time of the project. Okay? And we will also do the summation of variance of completion time of each activity, and that we will require to find out the probability of completing the project in a certain duration, in a fixed duration. So we will also calculate here at this stage the sum of variance of completion of the project. In step 2, we calculated variance of completion time of each activity. Here we will calculate variance of completion time of the project, that is summation of Vij. Here again, in step 2, we calculated variance of completion time of each activity. But when we calculate summation of variance of Vij, actually Ij activities are the critical activities. When you calculate summation Vij, here Ij activities are the critical activities on the critical paths. So to calculate variance of completion time of the project, you sum up, you take the summation of variance of critical activities, variance of completion time of critical activities on the critical path. Okay? Now step 5. In step 5, we will simply determine the probability. In step 5, we determine the probability of completing the project in a certain fixed completion time. This is step 5. So these are, in short, the different steps for calculating the expected project completion time, and also for calculating the probability of completing a project in a certain fixed completion time. Let us understand these steps a little bit more in details. I have already told you in step 1 we had to draw the network diagram. Step 1 was for drawing the network diagram. And step 2, in step 2 we talked about calculation of expected completion time and variance of completion time of each activity. In step 2, what we will do, we will calculate expected completion time. We will calculate expected completion time and variance of completion time of each activity. This is what we will do in step 2. And for this, the required formula, expected completion time, that is of Ij activity, each activity, expected completion time of each activity Tij will be calculated by this formula, A plus 4m plus b divided by 6, and variance of completion time of each activity, Ij activity, will be calculated by this formula, b minus a divided by 6 whole to the power 2 square of b minus a by 6 in the square of this. Now here a, b and m, what are these things? Here actually a, m, b. A stands for optimistic time of completing the activity, completing one activity. Pessimistic time of completing one activity, that activity, Ij activity. So for that particular activity, most likely time is denoted by m. So A, M, B are for each activity. For one activity, A is optimistic time, B is pessimistic time, M is most likely time. For example, if optimistic time is 8 weeks in completing one activity, pessimistic time will be, of course, more than 8 weeks. pessimistic time will be maybe 12 weeks, and most likely time will be somewhere between optimistic and pessimistic time. Okay, so with all these things, optimistic, pessimistic and most likely time, will calculate expected completion time of each activity, Tij, and variance of completion time of each activity, Vij, using these two formula. And for calculating Vij and Tij, Tij expected completion time of each activity, and Vij variance of completion time of each activity. For calculating these two things, we'll use this table. Okay. Move on to the next step. In step 3, I have already explained, I have already told you, in step 3, we'll calculate the critical paths. Critical paths of project, and here the critical paths we'll calculate using the applying the longest path methods. So critical path of the project is the longest path. Critical path, we'll calculate critical path of the project using the longest path from the initial node to the terminal node of the project, which I understood earlier very well. The project with the expected completion time, of course, with the expected completion times of each activity, which you calculated in step 2. So using expected completion time of each activity, we will determine the critical path, which is the longest path of the project among many paths. Step 3. Now step 4. In step 4, actually, in step 3, already we have understood, we have already determined the, after step 3, we can already calculate the expected project completion time, which is the completion time of the critical path. Once you determine the critical path with the longest path, and duration of that critical path is actually the expected completion time of the project. So expected completion time of the project is the duration of the critical path. So we can say expected completion time of the project, expected project duration is the duration of the critical path. Expected project duration is summation of Tij for critical path. So obviously duration of critical path, this is simply duration of the critical path. You can say expected project completion time, expected project duration or expected project completion time is denoted as mu. It is pronounced as mu, summation Tij for critical path. So simply speaking, expected project duration is duration of the critical path. Expected project duration is duration of critical path. Then variance of project duration, variance, the sigma, variance of project duration, sigma square. Sigma is standard deviation, and sigma is used for standard deviation, and sigma square is variance. So variance of project duration. In step 2, we calculated variance of completion of each activity. Now we are talking about variance of project duration, variance of completion of project. So that is sigma square. Sigma square is summation of Vij for critical path. Here again, you should understand clearly, it is for critical path. That means all the critical activities, summation, we take the summation of Vij for critical activities on the critical path. So that way we calculate mu. Mu stands for average or expected duration of the project, which is sum of Tij for critical path, and variance sigma square. Variance is variance of project duration, which is sum of variance of each activity, sum of variance of each activity of the for the critical path of the critical activities. Of the critical activities on the critical path, that is sigma square, variance of project duration. So, of course, variance sigma square, variance is summation of Vij for critical activities. Standard deviation of the project duration will be sigma. I have already told you sigma is for standard deviation and sigma square is variance. So variance is this. So therefore, standard deviation will be square root of summation of Vij. Summation of Vij, then square root of this is standard deviation. Obviously, if this is variance, the standard deviation will be square root of summation of Vij. For, again, don't forget, always remember, all these things will be for critical path. Actually, I repeat, we have already calculated expected completion time or duration of the project, which is mu. Now, we need to calculate standard deviation of project completion time in terms of sigma, which is square root of summation of Vij for critical path, to calculate actually the probability of completing the project in certain days. Say if it is in terms of days, in T days. Probability of completing the project in T days, and which is fixed. Suppose, for example, you have calculated expected project completion time is 50 days. You have calculated expected project completion time is 50 days. Now, in step 5, we are going to calculate what is the probability of completing the project in 45 days. So, T stands for here 45. I repeat, if mu is expected project completion time, say expected project completion time mu is 50. Now, in step 5, we will calculate the probability of completing the project in, say, 45 days. That means T stands for 45. How will be done that? How we will do that? So, we will write probability of completing the project in T days. That is probability x less than or equal to T, probability z less than or equal to T minus U divided by sigma. This equation or this calculation is done on the basis of, on the understanding that z is x minus z stands for x minus mu by sigma, and x is what? X is random variable. X is a random variable for expected completion time. X is a random variable. Random variable for expected completion time of the project following normal distribution, following normal probability distribution. So, if X stands for a random variable for expected completion time, random variable for expected completion time. Expected completion time will be, here we calculated expected completion time is 50. So, random variable 50, 51, 52, 54, 48, 47, 46, these are random variables. So, if X stands for random variable for expected completion time of the project following normal probability distribution, and Z stands for X minus mu. Mu is expected completion time of the project, and sigma is standard deviation of project duration. Standard deviation of project duration. Sigma is standard deviation of project duration, and mu is expected completion time of the project, and X is the random variable of expected completion time. So, the formula we will use here when we calculate probability of completing the project in T days, say 45 days, we will calculate probability X is less than or equal to T. That is probability Z less than or equal to this. So, after calculating this thing, probability from Z table, we will use Z table. Using Z table, Z score, we will determine the probability. And how it will be done, we will see in the next when we solve the problem. So, shall solve one illustration. So, let us move on. So, these are the steps. So, with this understanding, we will now go for solving the illustration. This is the illustration. illustration for computation of expected project completion time, and of course in this illustration we will also calculate the probability of completing the project in a certain fixed number of days. So illustration says a project consists of 9 activities which are indicated by A, B, C. These are the activities. A, B, C, D are the activities, and the 9 activities. And here given the precedence relationship, time estimates and precedence relationship are given. So what are the things given? Time estimates and precedence relationship are given. So this is the precedence relationship, preceding activities, and time estimates. For each activity, time estimates are given. Optimistic time, pessimistic time. I told you, pessimistic time must always be greater than optimistic time and most likely time. Most likely time must be somewhere between optimistic and pessimistic time. So for each activity, optimistic, pessimistic and most likely times are given, and from this data we have to calculate. First you have to draw the network diagram. And then we'll have to calculate, we'll have to determine the critical path. And of course from critical path we have to calculate expected project completion time. We have to compute the expected project completion time, and finally we have to determine the probability of completing the project in 55 days. We have to determine probability of completing the project in 55 days. So let us start solving the problem. First of all, we have to draw the network diagram. So let us draw the network diagram first. Here, these are the activities A to I, and preceding activities, precedence relationship. See, here you find activity A has no preceding activity, whereas B and C have preceding activity A. That means A is preceding activity of B and A is preceding activity of C. So since A has no preceding activity, so let us draw activity A. Activity A. This is activity A. This is activity A, which has no preceding activity. But activity B and C have common preceding activity. So let us this be B, activity B, and this is activity C. And then D, activity D, so we have seen activity A has no preceding activity, and activity B and C have preceding activities A. So B has preceding activity A, C has preceding activity A. Now activity D has preceding activity B. So let us, and also activity E also has preceding activity B. So let us draw activity E. This is activity E, and let us draw activity D. This is activity D. Activity D. Activity D. Now see, activity D has preceding activity B, and activity E also has preceding activity B. Now activity F. After activity D and activity F, E also we have drawn activity E. and we find activity I starts from one node, which is the merged node, and where two activities G and H are merging. G and H, two activities merging in a node from where I starts. So this must be one node where two activities G and H, and G comes from after activity E. So here G has preceding activity E, so this is G, and H has preceding activity D and F. So D and F, these two are preceding activities of H. So this H, this is activity H. This is activity H, which has two preceding activities D and F, and G is the activity which has one preceding activity E, and finally activity I is coming out from this node, which is the merged node of two merging activities G and H. So I is the activity here. The last activity is I, which has two preceding activities G and H. So this is network diagram. This is the network diagram. Okay, this is the network diagram. Now let us give node numbers. Let us use the node numbers to understand this better later on. Node number 1, node number 2, node 3, node 4, node 5, node 6, node 7 and node 8. There are 8 nodes and there are 9 activities. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 activities and 8 nodes. And these are the paths we have drawn. This is the network diagram. And after this network diagram is drawn, what we will do next? We will calculate actually expected project completion time of each activity. So to compute expected project completion time of each activity, we will use this table, and here we will first put on the activities and their duration, time estimates. So activities are A, B, C, D, E, F, G, H, I. So these activities, 9 activities, 4, 5, 6, 7, 9. So these activities, and in terms of these activities, now in terms of nodes, so activity 1, activity A 1, 2, activity A 1, 2, activity B 2, 3, activity C 2, 4, activity D 3, 6, activity D 3, 6, 3, 6 is activity D, activity E 3, 5, so put it here 3, 5, activity F 4, 6, so put it here 4, 6, activity G, where is activity G? 5, 7, so put it here 5, 7, activity H activity H 6 7, put it here 6 7, and activity I 7 8, 7 8. Now let us put the duration, time duration, time estimates. Let us put the time estimates which is given in the problem. Time estimates are given in the problem. So let us put the time estimates. For activity A, time estimates are 4 6 8. Time estimates are 4 6 8. For activity B, time estimates are 5 7 15. So 5 7 15, and this way 4 8 12, then 15 20 25, 15 20 25, 10 18 26, 10 18 26, then 10 18 26, then for F, activity F 8 9 16, 8 9 16, activity G 4 8 12, 4 8 12, activity H 1 2 3, 1 2 3, activity I 6 7 8. Now we will calculate expected time of each activity. We will calculate expected time of each activity by using this formula. Formula is A plus 4m plus B divided by 6. That means we'll see just one calculation, then we'll put on these things. 4 plus 4m 24 plus 8b whole divided by 6, which comes to 6, okay. And here again b minus a 8 minus 4 divided by 6 whole square. This comes to 4 by 6 2 by 3 whole square. That means 4 by 9. So this is how we will calculate expected time of each activity and variance of completion time of each activity. This is variance of completion time of each activity. This is expected completion time of each activity. So this way we calculate for other activities. So for activity B, this is 8 and this is 25 by 9. For activity C, this is again 8 and this is 16 by 9. For activity D, this is 20 and this is 25 by 9. For activity E, expected completion time is 18 and variance of completion time is 64 by 9. For activity F, expected completion time is 10 and variance of completion time is 16 by 9. For activity G, expected completion time is 8. Variance of completion time is 16 by 9 again. And activity H has expected completion time 2 and variance of completion time 1 by 9. For activity I, expected completion time is 7 and variance of completion time is 1 by 9. 1 by 9. So these are expected completion time of each activity and these are variance of completion time of each activity. Now what we have to do? We have to put these expected completion time in the network diagram for each activity. Put this expected completion time which you calculated here, expected completion time of each activity. So put these each activity expected completion time for each activity. So activity A, activity 1, 2, activity A. For this expected completion time is 6. Expected completion time is 6. And for B, activity B, expected completion time is 8. For C, expected completion time is again 8. For D, expected completion time is 20. Expected completion time 20. For E, expected completion time 18. F, expected completion time 10. G, expected completion time 8. H, expected completion time 2. And I, expected completion time 7. Now, after putting all this expected completion time of each activity, the next thing we'll calculate the critical path. There are different paths, and out of these paths we calculate the critical path, which is the longest path, having longest duration. So what are the paths? Different paths. 1, 2, 3, 5. One path is 1, 2, 3, then 1, 2, 3, 5, 7, and 8. This is one path. Another path. And what is the duration? So let us see what is the duration. Duration 6 plus 8 plus 18. 6 plus 8 plus 18 plus 8 plus 7. Six plus 8 plus 18 plus 8 plus 7, which equals to 47. 47 which equals to 47 days. Now another path. 1, 2, 3, 6, 7. 1, 2, 3, 6, 7, 8. 1, 2, 3, 6, 7, 8. So 1, 2, 6, 2, 3, 8, 3, 6, 20, 6, 7, 2, and 7, 8, 7. What is the duration of this path? 6, 8, 20, 2, 7. What is the duration of this path? 43 days. 43 days. Now another path, the last one. This diagram has 3 paths. The last one, 1, 2, 4. 1, 2, 4, 6, 7, 8. So 1 to 6, 2 to 4, 8, 4 to 6, 10, 6, 7, 2, and 7, 8, 7. 6, 8, 10, to 7. 6, 8 to 6, 8, 10 to 7 is the total duration of activities 33 days. 33 days. So these are the 3 parts and this is the duration of each part. So obviously critical path is this one, which is having the longest duration, 47 days. So this is the critical path, longest duration. This is the so here the critical path is, this is the critical path which has longest duration, 47 days. That means the critical path is 1, 2, 3. 1, 2, 3, then 3 to 5, then 5 to 7, and 7, 8. This is the critical path. 1, 2, 3, 5, 7, 8. 1, 2, 3, 5, 7 is the critical path, and duration of this path is 47 days. And actually, expected project completion time, expected project duration is 47 days. That was the requirement of the illustration. Requirement of the illustration was, after drawing the network diagram, determine the critical path and compute expected project completion time. After drawing the network diagram, we have to determine the critical path and compute expected project completion time. So expected project completion time. So therefore, critical path is 1, 2, 3, 5, 7, 8. 1, 2, 3, 5, 7, 8 is the critical path, and expected project completion time. And expected project completion time is 47 days. This is 47 days. Expected project completion time is 47 days. So this one answer we've got, and the next we have to calculate the probability. We have to determine the probability of completing the project in 55 days. So for that we need to have sum of variance of completion time for critical activities, and also sum of variance of expected completion time of critical activities. So here we have identified the critical activities. As 1, 2, activity 1, 2, this is critical. Activity 1, 2, this is critical. Then 2, 3 is also critical. Then 3, 5 is critical. Where is this? 3, 5 is critical. 3, 5 is critical. Then where is 5, 7? 5, 7 is critical. And 7, 8 is critical. So these are the activities, 5 activities which are critical, having the critical path. So 1, 2, 2, 3, 3, 5, 5, 7, 7, 8. These are the critical activities, and this is the expected completion time of critical activities. And here variance of completion time of critical activities. So these are variance of 4 by 9, 25 by 9, 64 by 9, this and this. These are the variance of completion time of critical activities. These are variances of completion time of critical activities. These are expected completion time of critical activities. So from these we find summation of Tij. Summation Tij. Now what is summation Tij? Summation Tij. So we calculate summation Tij. Summation Tij. Summation Tij, expected project completion time. Expected sum of expected completion time of each activity. That is 6 plus 8, which is actually the completion time of the project. 6 plus 8 plus 18 plus 8 plus 7. 6, 8, 18 plus 8 plus 7 is 47. So 47 is summation of Tij, 47 days. This is summation of Tij, expected completion time, summation of expected completion time of critical activities. Now you calculate summation of Vij. Summation Vij. V is variance of completion of each activity. Summation Vij. Summation Vij. Summation Vij. Remember, summation Vij, variance of completion time of each critical activity. Variance of completion time of, first we calculate variance of completion time of each activity, but now summation, we take summation of variance of completion time of critical activities. So here it is 4 by 9 plus 25 by 9 plus 64 by 9 plus 16 by 9 and 1 by 9. 4 by 9, 25 by 9, 64 by 9, 16 by 9 and 1 by 9. So what is the total of this? This is the total of this is 110. So putting these things, we find out the total of this, total of all these variance of completion time of activities. This is the variance of completion time of each activities, and total of this is 110 by 9. 110 by 9 is the total of variance of completion time of each critical activities. Variance of completion time of each critical activity, and total of this is 110 by 9. Now, for determining the expected, for determining the probability of completing the project in 55 days, we need to have two things, mu and sigma. This is the variance. This is sigma square. Implies sigma square. This implies sigma square, the variance. Summation of variance of the project. So we need to have mu. This is mu, expected completion time. Therefore, expected completion time of the project mu is 47 days, and standard deviation of the project completion time, sigma is square root of 110 by 9. This comes to 3.496. How do you calculate that? It's simple. 110 divided by 9 and then square root of answer. This gives 3.496. So 3.496. I repeat the calculation. How to calculate this? First 110 divided by 9, then square root answer, and you get 3.496. 3.496 is the standard deviation of the project completion time. So you've got expected project completion time and standard deviation project completion time. Now we will calculate. Probability of completing the project in 55 days. Therefore, probability of completing the project in 55 days. In 55 days, we will write P probability X random variable, which is for completion time of the project. This is random variable for completion time of the project, which is less than or equal to 55. So probability of completing the project in 55 days is probability random variable X, which is less than or equal to 55, and this equals to, using normal probability distribution, you can write equal to, using normal probability distribution, equals to probability Z is less than or equal to 55 minus mu by sigma. Here mu we have already calculated. Mu is 47. So probability Z less than or equal to 55 minus 47 divided by sigma, we calculated 3.496. 3.496. This is just distribution table, Z distribution table or standard normal distribution table, Z score table. Here it starts from minus 3.96. Actually left side of Z, left hand side of Z area. If you have done probability, normal probability distribution, probability distribution, then you will understand. So let us find from this table easily. You can find it, the probability from this table easily. So our calculation says probability of Z, which is less than or equal to 2.29. So to find out 2.29, 2.2 is here, 2.2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. The last column is for 9, 2.29. 2.2 you get here, and towards right, you go towards right after 2.2 for this 9. So 2.2, then go to the right. So this is the value for 2.29, 2.2 and then 9, 2.2, because we have 2.29 value, which should Z should be less than or equal to 2.29. The value of Z probability, total probability, Z less than Z should be this 2.29. Z, the value of Z is 2.29, and probability less than Z. Actually, this is read as this. The value of Z is 2.29, and we need to have probability less than Z area under normal distribution, curve. The less than Z, the value is the probability we require here. So probability less than Z, 2.29 is when Z is 2.29. Z is 2.29, less than Z, total probability under the normal distribution curve is this 0.98899. What is that? 0.98899. 0.98899. The probability 0.98899 is the probability as per normal distribution, using normal distribution technique, normal distribution model under the normal distribution curve. I repeat, Z is one line perpendicular to the x-axis in the normal distribution curve, and which stands for 2.29, and we need to find out the probability left hand side of Z, the total probability left side of the Z under the normal distribution curve, which is 0.98899, and approximately we can say the probability is 98.9%. Approximately 98.9% approx. In terms of percentage, approx. So approximately 98.9%. So the probability of completing the project in 55 days, therefore probability of completing the project in 55 days is 98.9%. So this is the class for today. We have completed the whole thing. Let us sum up the illustration. So what is the illustration part is called the sum up the process of calculation or method of completing the illustration. So this was the illustration. From the illustration, we drew the network, and after drawing the network, we calculated expected project completion time of each activity and variance of completion time of each activity, and putting expected completion time of each activity in the diagram, in the network diagram. In the network diagram, we put all the expected completion time of activities, and from there we calculated the critical path by longest duration method, longest path method. Longest duration. There are 3 paths, and these 3 paths, this first one has the longest duration, 47 days. So the first one is the critical path. The critical path is 1, 2, 3, 5, 7, 8 is the critical path. Once you know the critical paths, therefore critical path is 1, 2, 3, 5, 7, 8, and expected project completion time is the duration of the critical path, 47 days. This is the expected completion. Actually, we have got the critical path with expected completion time of each activity. 6 is expected completion time of this activity, 8 is expected completion time of activity B, and 18 is expected completion time. Expected completion time is calculated using pessimistic, optimistic, and most likely time of this activity. So that way we calculated expected completion time of each activity, and using this we got the critical path, which has duration 47 days. So obviously expected completion time, expected project completion time is 47 days. And after calculating expected completion time of the project, we have to calculate the probability of completing the project in 55 days. For that, we need to have these two things: summation of expected completion time of critical activities and summation of variance of completion time of critical activities. I repeat, summation of expected completion time of critical activities and summation of variance of completion time of critical activities. And these are the critical activities: A, B, E, G, I. These are critical activities. We have already seen that. And taking all these critical activities and taking actual completion time of these critical activities and variance of completion time of critical activities, we calculate sum of Tij, which is 47, is already you have calculated the actual completion time of project, and sum of Wij. Sum of Wij is the variance. This is variance of the project. This is variance of the project. This you can say, this is variance of completion time of project. This is variance of completion, variance of completion time of the project. This is variance of completion time of the project. Variance of completion time of the project. So, mu, which stands for expected completion time of the project, is 47 days, and sigma square is the variance, sigma is standard deviation. The standard deviation is square root of this variance, 110 by 9, and this comes to, this is square root of variance is sigma, standard deviation. This comes to 3.496. So after calculating mu and sigma, we calculate the probability of completing the project in 55 days. Therefore, probability of completing the project in 55 days is probability of x. X is the random variable for expected completion time of the project. So x less than or equal to 55. So probability is that 55 minus mu by sigma as per normal distribution method. Probability of normal distribution. So probability of z is 55 minus mu is 47, and 3.496 is the calculation we have calculated for standard deviation, 3.496, and calculating this we get 2.29. Probability of z less than or equal to 2.29. Z is actually the perpendicular line under the normal distribution curve, which is here for 2.29. So we have to calculate the total probability under the normal distribution curve towards left of z. Z stands for the perpendicular line on x-axis under the normal distribution curve, the bell-shaped normal distribution curve. Z is for 2.29. We have to calculate total probability towards the left of z, where z is 2.29. So probability of z less than or equal to 2.29 comes to from this table, z distribution table. From z distribution table we find 2.2 and 2.29. See, we get 0.98899. 0.98899 is the probability. In terms of percentage, this is the decimal point, and in terms of percentage, 98.9% is the probability of completing the project in 55 days. Thank you, students. Thank you for attending my class, this channel. Thank you all. Thank you very much.